Hi everyone. In this video, we're going to be taking a look at horizontal and vertical translations of y is equal to x squared. Now, to start off, we're going to be taking a look at how we can graph y is equal to x squared. Because we need to know that to look at how we can transform this graph. So to graph y is equal to x squared, one of the ways we can do that is by using a table of values. And to use a table of values, what we're going to do is we're going to plug in different values of x into our equation here and see what y value you get back. Then, once we know our x and y values, these will form a point. And we're going to plot these points on the graph to see what our graph of y is equal to x squared will look like. So first, we're going to plug in x is equal to -3 into our equation. So if we plug in -3, we're just going to square that to get y. -3 squared. Well, -3 times -3 is just 9. Okay, if we plug in -2, same thing. Okay, we're just going to square -2. And -2 times -2 is just +4. And we can keep going, right? If you plug in -1, well, -1 squared. -1 times -1 is just 1. If we plug in 0, 0 squared is just 0. If we plug in 1, 1 squared is just 1. If we plug in 2, 2 squared is just 4. And if you plug in 3, 3 squared is just 9. So what you'll notice is we have x and y coordinates here. So we can plug these points in on our graph to see what it's going to look like. So let's do that. So the first point I'm going to plug in is -3, 9. And to plot that point, I'm going to see where x is equal to -3, and then go all the way up to where y is equal to 9. And that's going to be my first point. My next point is -2, 4. So I'm going to go where x is equal to -2, and then go all the way up to where y is equal to 4. And there's my next point. And I can keep going. Okay, I'm going to plot the point -1, 1, then 0, 0, then 1, 1, then 2, 4, then 3, 9. And now I can just connect these points with a curve. And this is what my graph of y is equal to x squared looks like. Now, the reason I wanted to look at the graph of y is equal to x squared is that's going to help us when we take a look at transformations of this graph. Like, what's going to happen if I add or subtract different values to this function? How will that affect my graph? That's what we're going to be taking a look at in this video. And to help me introduce this, I want to open up Desmos here and see what that looks like. So here, I have a graph of y is equal to x squared plus k. Now, k is some number, right? So we're imagining we're adding some number to y is equal to x squared. It could be 2, it could be 5, it could be any number. What we want to look at is see how is that going to affect my graph? So for example, let's look at if I added 1, k is equal to 1 to my graph. Now this parabola on the bottom represents y is equal to x squared, and this parabola at the top represents y is equal to x squared plus 1. Now we can see, if you zoom in here, right, y is equal to x squared plus 1, well, we just shifted this graph up 1 unit. Let's look at y is equal to x squared plus 2. Y is equal to x squared plus 2 is shifted up 2 units. And we can keep going, right? Y is equal to x squared plus 3 will be shifted up 3 units. Okay, another question we can ask is what happens if this number here is negative though? Like what if I had like a negative number? Well, let's see. If I have negative 1, then what I'm doing is I'm shifting the graph down 1. If I have negative 2, then I'm shifting the graph down 2. So if we're adding a value to x squared, if the value we're adding is positive, then that's going to shift the graph up. And if the value we're adding is negative, then that's going to shift the graph down. So let's write that down. So again, we saw, if the value we're adding, k, is positive, right? If k is positive, then what does that mean? We shift the graph up. And if k is negative, then we're going to shift the graph down. And let's take a look at a couple examples just to make sure that that makes sense. So, say we had something like this. Y is equal to x squared plus 5. Now you'll see, my k value is positive 5. And since this is positive, that means we're going to go up. Right? We're going to go up 5 units in this example. If I had something like this, y is equal to x squared minus 7, then my k value here is negative. And since it's negative, that means we're going to go down. And in this case, we're going to go down 7 units. Okay, another type of transformation we're going to look at is, say we're subtracting a number from x. Right? Say I'm subtracting a number, we're going to call it h from x. Let's see how that's going to affect our graph. So, this blue parabola represents y is equal to x squared. We're going to see how subtracting a number from x will affect our graph. So, say I'm subtracting a positive number. So say I'm subtracting 1. Let's take a look. If I'm subtracting 1 from x, x minus 1, and then squaring it, okay, we can see our graph, our graph here on the right, is going to be shifted 1 unit to the right. If I'm subtracting 2 from x, my graph is going to be shifted 2 units to the right. And if I subtract 3 from x, my graph is going to be shifted 3 units to the right. So we can see, if I'm subtracting a positive number, if my h value here is positive, then that's going to shift my graph to the right. Again, a question we can ask here is, what if our value was negative? Well, if our value was negative 1, for example, then all that's going to do is that's going to shift my graph to the left. So you can see now, if you subtract, say, a positive number from x, that's going to shift my graph to the right. And if I subtract a negative number from x, that's going to shift my graph to the left. And let's take a look at some examples to make sure that that makes sense. So say I had something like this. Y is equal to x minus 1 squared. Now my h value here is going to be 1. I'm subtracting 1. So my h value is just 1. And since this value is positive, that means I'm going to shift my graph to the right. Now, say I had something like this. Y is equal to x minus negative 2 squared. X minus negative 2, well, negative times a negative, that makes a positive. So this is the same thing as writing y is equal to x plus 2 squared. Now we can see my h value here is going to be negative, which means I shift my graph to the left by 2 units. Let's take a look at these examples in action now. So say I wanted to graph y is equal to x squared plus 3. Well, we're going to start off by identifying what are the transformations that are involved. So first I can see I'm adding 3, right? I'm adding 3 here. Since I'm adding 3 to x squared, that means I'm going to shift my graph up 3 units. So let's start by graphing y is equal to x squared. And whenever we're doing this, we always want to start by graphing y is equal to x squared. And then we're going to use our graph of y is equal to x squared to graph my new function here. And I'm just graphing this. I'm just graphing y is equal to x squared, just thinking back to the table of values I used earlier, the points I plotted earlier. Now, all I want to do is I want to shift my points here up 3 units. So let's take a look. So say I have my point right here. To graph my new function, I'm just going to shift this point up 3 units. And there's my new point. Okay, now, this next one. I'm going to take this point and shift it up 1, 2, 3 units. And I'm going to do the same thing with the other ones, right? I'm going to just shift each point up 3 units to see what it looks like. Okay, there are my new points. And now all I have to do is just connect these points with a curve like this. And there we go. There is my equation. What if I have something like this? X minus 3 squared. Now for this one, I'm subtracting 3 inside my brackets. Now my h value here is going to be positive 3, right? Right? Since my h value here is going to be 3, that means I'm going to shift my graph right to the right 3 units. Okay, so let's do that. So again, I'm going to start by graphing y is equal to x squared. And then all I'm going to do from there is I'm just going to shift my graph right 3 units. So let's do that. I'm going to take my points here and move them 3 units to the right. So take this point, for example, and count 1, 2, 3 units to the right. And take this point, go 1, 2, 3 units to the right. And I'm just going to do the same thing with each of the points here. I'm just going to shift my points here 3 units to the right to see what this graph is going to look like. And now I'm just going to connect these points with a curve here. And there's my equation. There's my graph of y is equal to x squared minus x minus 3 squared. So all I'm doing here to graph my new functions is I'm starting off by graphing y is equal to x squared and then identifying the transformations to help me graph the new function. Let's take a look at one more example. Y is equal to x plus 1 squared minus 2. So first we'll notice we're adding 1 inside the brackets. So something you might remember is x plus 1. That's the same thing as x minus negative 1. So what does that mean? That means my h value here is going to be negative 1. And remember, if my h value is negative, I'm going to shift my graph to the left. So what I'm going to do here is I'm going to shift my graph 1 unit to the left. And here, since I have minus 2 outside of the brackets, well, since this value is negative, my k value here is negative, I'm going to shift my graph down. Right, so I'm going to shift my graph down 2 units. And now to graph this, I'm just going to start by graphing y is equal to x squared. And then I'm going to take each of my points and shift them left 1 unit and down 2 units. So again, all I'm going to do now is I'm going to take my points, shift them left 1 unit and down 2 units. And that's going to give my new point. I'm going to take this one, again, same thing. Shift it left 1, down 2. Left 1, down 2. And so on. Left 1, down 2. Left 1, down 2. And there we go. So, in summary, all we need to do to graph these transformations is first, we're going to start by graphing y is equal to x squared. Then we're going to identify what transformations are involved here and use those transformations to plot my new points.